Yeah, welcome guys. So let's let's deal with this, the third one, which is the last one. So before we start, let's import it for the annotation so we don't forget. So for this one, so we should use create a method to return a dictionary with the following key value pairs. First one will be the current start index of the return page, and then second one should be the next index, third one should be page size, and the fourth one should be data, the actual page of the data set. And then requirement slash behavior, we should use start to verify that index is in a valid range, and if the user queries index 0 and page size 10, they will get rows index 0 to 9 included. And if they request the next index, which is 10 with page size 10, but rows 3, 6 and 7 were deleted, the user should still receive rows index 10 to 19 included. Yeah, so let's get started. Here we have to use assert to ensure that both index and page size are integers. Now we check if page size is an integer, and then again we use assert to ensure that the index is always in a valid range. First, check that 0 will always be less than or equal to the index, and the index will always be less than the length of the data set itself. Or the index is none. So with that out of the way, we are going to initialize an empty list called data. So this empty data is going to use to store all items or rows for the current page as required by the task. So we need to get the next page, the next index. So this is the formula for getting the next index. Index plus next page, page size. If you still find it hard for indexing, check out the view that is on your screen right now. It's going to clarify you on indexing and pagination. Once you learn pagination and indexing, this task won't be nothing. Next, we iterate through with a for loop to get the data for the current page. And then we set the start of the loop as index, and then next page, next index as the stop. And then we are going to check if the data exists or has been deleted in the current index, because here they say we should request the next index, but if the rows that are requested, if a couple of them is deleted, so the user should still receive the complete size of the page. That's why we are going to check if the data exists or has been deleted in the current index. So we say if not self dot index dataset dot get, we use the get, we chain it with the get function to check each row. And then if it has been removed or deleted, we increment I by 1, skipping it, and then we adjust the next index, because if a row has been deleted, so we don't need to hold on to the row that has been deleted, we have to increment by 1, and then the next index, assuming the page is supposed to be 20 items, and then next index is 20. If one row has been deleted, we will still leave the next index at 20, which means the page is going to contain not 20 items anymore, but 19 items. So that's why we have to increment next index by 1, so the page will still hold on to 20 items as required. And then after checking this, then we append all the items or rows to the variable data. See. Then we pass I. And then now we create and compute the values. Let's say value name is going to be hyper data. So we say index is index so data is data. Then page size is page size. And then next index is next index. Finally we return hyperdata. So I did not create another file to test this, I just moved them to the main. So let's save and test. So if you find this video helpful, please like and subscribe if you are yet to do so. So here you see Emily and Emily. I've been playing with the data set, that's why the head is no longer correct. So yeah, that is it.